All right, welcome everybody to the Young African Scientists platform. This is the engine, and we are doing a machine learning training at the moment. We are at lecture 7, and we are going to look at decision tree and other modules that you will see in your machine learning. And today, the person handling the meeting and the facilitator of the meeting is Dr. Senyo. So, Senyo, if you're around, you can unmute and you can start setting yourself up for the meeting. Now, I'm going to put the attendance link in the chat box, so please do well to register. We are almost at the end, so make sure you don't miss any of our meetings. If you have not been attending some of the meetings, now is the time to make up, because we have about 3 more, and then we'll be done with a whole course and you will get your certificates. So please do well to organize yourself as we go towards the end. And you're going to be a part of uh, the projects that will be done, and that will also score some points for you as well. So I will now hand you over to your teacher. Today we are going to look at decision trees and the other modules that he has prepared for. So Dr. Senyo, are you around, Senyo? If you're talking, then
Yes,
yes,
I'm around. I'm
yes,
around.
yes. Good to see you, my man. Good to see
Thank
you.
you.
So please, hand over the class to you. We have 1.5 hours, so please make sure you do everything within that time. All right. Thank you.
Thank you. Just give me just a second. Just a second, please.
So as he gets himself ready, if you have not registered for this course, then you need to register. If you're not part of the WhatsApp group, you can send me a message and I'll add you. If you have not registered for next week's presentation, next week we are going to have Professor Gibisa Ijeta, and he is one of the legends that we have still alive. This is a man who has won uh, food prizes with the president of US, and he's quite involved with a lot of projects from UN and stuff that are going on the planet. And he's also a professor at Purdue University. Done a lot of research, into uh, modification of plants and agriculture and all those things. He is a person to listen to. I've interacted with him a couple of times, and he's always focused on trying to get us to get to the next level. Now, we are not going to have a formal speech. It's going to be an interactive session. We are going to talk to him. So we'll ask him a couple of questions. He's going to answer all those questions. And then if you have any question, you can ask him based on what we are talking about. And it's going to be a free flow chat kind of meeting. So it's something you really have to be a part of. And wherever you are in your profession, this is a place that you need to be so that you can get the information that are relevant to you. All right. So, Senor, if you're ready, please go ahead.
Yep, I'm ready.
Okay, please take over.
Thank you. Um, please help me confirm what is currently on my screen. I want to be sure I'm showing the right thing.
You're showing us Google.
Okay. Okay, so I think it's the same thing again. Um, let me do this.
Yeah, we see the presentation now.
See the presentation now. Okay, that's fine. So yes, it will be less of talking, more of practicals. We have 1.5 hours, but before we start, I don't know, I'm always that guy, that Oliver Twist who always asks for more. So probably, if possible, I'll request that next week, Friday, I know it's also a free time. I'll probably want to come back again next week, Friday, because we may not be able to cover everything today. If that is allowed, then maybe next week, Friday, I will come back.
Next week, Friday, is a presentation from Professor Gibisa.
Oh, sorry.
Yeah.
Okay.
So what we can do is we can do
Mm.
the Friday after that. The
Okay,
Friday
the
after
Friday.
that is actually a class. So if everybody agrees, then we can probably do it 1 hour before Professor Gibisa comes.
Okay, that's fine.
Yeah.
That's fine. I'm happy to do that.
Yeah.
Right. So we're talking about decision trees today, and it's it's one of the um, non-parametric supervised machine learning methods that we have. It's a nonlinear algorithm, and it can be used for both classification and regression. I am sure by now we all can identify what classification is and what regression is. So yes, decision tree can be used for both. So if you are doing a research which involves classification, you can use decision tree. If you are doing a research which involves a regression, you can still use decision tree. So for classification, in case you want to build a model that will predict whether students will pass or fail, or whether an email will be a spam or not spam. Sorry, this side, whether a loan will be granted or you'll be denied a loan and all of that. That is classification generally. Or for regression, if you want to predict stocks or you want to predict weather or some economic growth, whether GDP or whatever it is that you are interested in, you can still use decision tree. So what we were doing today, we'll hover around decision trees, how it is built in Python, and also do a little bit of hyperparameter tutoring, which I know you have already done. So we'll do some hands-on training on decision trees. And for example, in the area of health, one can decide to use decision trees to classify tumors. We have different types of tumors. If you want to know which one somebody is likely to suffer from, we can use decision trees to do that, given certain characteristics of the tumor, such as the size, the shape, where it is located, and also looking at certain characteristics of the person as well, maybe the gender, the race, and all of that. So you can use that. But when you build the decision trees, it looks like what you have currently. It's like a tree, like the name suggests, decision tree. It's like a tree which has said some of these things. You have the root node, and there's a decision node, and all of that. Now, what is the root node? Anybody wants to try? Probably some of you have done something like this. Anybody want to try? What do you think is the root node? Right. So the root node just represents the entire population or sample which gets divided into branches. Right. So the entire population that you are dealing with is a root node. And from the root node, you're going to branch. And when you branch, you have to make a decision. A decision has to be made whenever you branch from the root node. So you can see these. Let me just use this to highlight it. From here, we make a decision to go either to the left or to the right. And these decisions that we make are based on certain conditions for a particular attribute. So we have so many attributes in our data, and to be able to make a decision and branch, it will depend on some conditions, and the conditions will be based on the attributes that we have in our data. So you keep branching, making decisions, branching, making decisions, and doing all of that until you get to where is the place which is called a terminal node. So the terminal node is the final place that you don't split any further. When you get to the terminal node, then there's no need to further split your tree. It can get longer than this. It can get longer than this. For example, a simple example one can think about would be, look, you want to make a decision to either go to sleep or to go to a restaurant based on certain parameters. You are hungry, but maybe you have only $50. So the root node here is somebody who is hungry. Are you hungry? Now, if you are hungry, hold on. If you are hungry, you are here. Sorry, the person is hungry. Are you hungry? Now we need to split that to either maybe a yes or a no. So maybe if I say yes, I go this way. If I say a no, maybe I'll go and sleep. But if I say yes, I am hungry, then I need to make further decisions. Do I have $50? Do I have $50? Then we can further split that to yes or no. Now, again, if I am hungry and I have $50, then where do I go? I go to the restaurant and go and buy food. It terminates there. If I am hungry, but I don't have $50, then it's no. It terminates there. I need to go back and sleep. So the tree is just in the form of this. You keep making decisions, splitting it down depending on whatever attributes that you have until you get to the terminal node where the final decision is made. So it's usually a top-down approach. And at each step, there is a split that you have to make. The split is what we saw earlier on. And the end node has a category that is the decision that you are going to make, whether you are going to grant the person the loan or you are going to deny the person the loan, or it may have a number, a continuous variable. So in terms of regression, it may have a number there. And one of the most common decision trees that we usually have is the CAT, classification and regression trees. There are other ones, but this is not the only one. There are other ones as well. You can have the shade and all of that, but the one that we will look at is the classification and regression trees. It's a popular decision tree algorithm And it uses certain metrics called the Gini impurity, which is just a measure of how often a randomly selected element from the set will be incorrectly labeled. So it uses some of these metrics to do the split. We'll look at that practically very soon. But then in decision trees, one of the things that you encounter very, very well in decision trees is overfitting. The tree can be overfitted. It becomes too large a complex and it becomes like too big. And because it becomes too large and very, very complex, something must be done to, to stop the overfitting or to avoid overfitting. And to avoid overfitting, a process called pruning is just like, think about it in your house. You have a tree which is growing. It's growing too big. What do? You take a cutlass and you go and chop off some of the branches because you think it's becoming too big. You chop it off just to keep it in shape. So that is what is called pruning. It's just trying to limit the depth of the tree, how the tree is growing. We do that also in machine learning just to avoid the tree becoming too large and very complex. And in pruning, we can have a pre-pruning and a post-pruning. Now, in pre-pruning, you want to stop the growth of the tree before it grows fully and overfits the data. Because this decision tree is so prone to overfitting, you want to avoid that issue of overfitting where you find that the model is doing very well on the training data, but if you introduce it to unseen data or test data, then it is suffering. So to do that, you need to make sure that the parameters of this model, you try to bound them in a way. You keep changing the values, especially some of them being the maximum depth, the minimum samples, and all of that. You try to keep the values in shape and trying to keep those values in shape or trying to make sure that they are within a certain bound is what I'm sure you did earlier on called hyperparameter tuning. So you are tuning them, making sure that you select the best possible combination of these parameters that you are going to use for the model. Yes, of course, for every model, you will have a base parameter value. You use that, you start off with that, and then you build a model. And when you think that the model overfit or the model is not too good, you want to further do what is called hyperparameter tuning, where you're trying to make sure that it's an optimization process. You're trying to select the best combinations of the different parameters that you are using for the model. And one of the most commonest ways of doing this hyperparameter tuning is using the grid search approach. The grid search, there are different methods of hyperparameter tuning. You can have the Bayesian approach as well. So, but the most commonest one is a grid search. Now, the post pruning is done by bounding what is called the cost complexity parameter. We'll go look at all of these very soon in the practical. So I think I'll just pause here and then go straight to Python so that we can have a look at how decision trees are built using Python and how do we interpret the model when the model is out. I'll pause. If there's any question, please ask before I go to Python. Is there any question from anyone? So we can go straight to Python, right? Okay,
Yeah,
thank
I
you.
think so.
So I have shared a data set. Please, do you have the data set?
Please check your
Yes,
WhatsApp.
we have.
The data set is
Okay.
there, but
Please
I'll email it to
download
everyone
it
soon.
and please open your Python so that we can start. Please confirm you can see my screen.
Yeah, we can see your screen.
Okay, thank you. So please, I've sent you the code, but what you need to do is to change the path. So what you see here, this is the path of my data, where my data is sitting. So you need to change this. I'm sure you know how to do that, do you? So you need to change this path.
Yeah.
Otherwise, if you run it with this, it will not work for you. So please change your path according to where, based on where your data is sitting. So the first thing that I want you to do is to be able to load the data. So please try and load the data. Load the data, and then we can start. I've given you some of the libraries that we will be using. You just need to run them. Then after that, you please load the data. So please do that. And once you have loaded the data, then I'll take you through the rest of the process. How many minutes should I give? How many, I don't know whether I should say minutes, seconds should I give you to load the data? Hello, how long should I give you, please? I'm not getting a response. Please give me a response. Okay, so have you now loaded the data? Maybe let me put it that way. Please, have you all been able to load the data?
Yes, you have the data.
Yeah, what I mean is load it and it is here because once we start running the code. Okay, so let me run it. So what I'm doing here in this line of code, I'm just trying to import or load the data into Python. I decide to call it diabetes. Whatever name you prefer to call it, you can give it that name. Just make sure that whatever name you give it, you must be consistent. So I just decided to call it diabetes. And it's an Excel file. You could be given a CSV or any other format. So when I run this, it loads my data. Then this is just giving me the first top observations. This is my data. The first 10 observations is what the data is displaying here. You can see the variables right on top there. This is a classification algorithm. This is the one that we want to predict the class. It's 1, 0, 1, 0. And these are the features we want to use to predict the class that the person will belong. It's either 1 or 0. So this is a classification problem. So this is just giving us an overview of how the data looks like. This gives us how many, how do you call it, observations we have and how many variables we have. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9, and then in total, there are 768 observations. This is our target variable. So all I'm trying to do here is trying to count how many of each we have. So how many zeros do I have and how many ones do I have? You can see here that the zeros are far more than the ones. So it's a classification algorithm, right? It could be pass or how do you call it? Or fail. Now, I'll ask a question before I continue. If you look at this, there is 0 and there is 1. The zeros are about 500 and the ones are 268. Is this balanced or is unbalanced? Is it a balanced data?
Balanced one.
Sorry?
It's not balanced.
It's not balanced, right?
Yes.
So if you were to use a data set which is not balanced, in this case, maybe it's skewed towards one of the classes. In this case, it is so skewed towards the 0. What do you think are some of the possible shortfalls of the model that you will build?
Come again?
So what I'm saying is that we can see that the target variable is not balanced, like you rightly said. Now, if you use this imbalanced data to build your model, what do you think are some of the disadvantages of that model that you are going to build using this imbalanced data?
The model assumptions is not is violated. That's then the decision you are going to take is not appropriate.
Okay, so it could some of the consequences could be some biasness, isn't it?
Yes, please.
Yeah, because imbalanced data can lead to some model bias because the model will be too skewed to the class which has the larger number. It will be skewed towards the 0 rather than the 1, right? So if you have to resolve this, what do you do? What can you do to resolve it? What do you think you can do to resolve this thing? Because when you usually, though we are not going to do that today, but I just want us to have that understanding. When you have in classification problems, this is very, very common, right? So when you have this, how do you address it?
Can we do hyperparameter?
No, we are not yet at the model yet. So we have the data. And in the data, the target variable that we are looking at. So maybe if you're talking about pass or fail, or maybe malignant or benign, or whatever the target variable is, you realize that if you see this, the zeros are more, they are far more than the 1. And we agree that it can lead to some biasness. Those are some of the consequences of using imbalanced data for your modeling. It can lead to, how do you call it? Some biasness. Because a model that you train on an imbalanced data, it may appear to have high accuracy, but it will perform poorly on the minority class. This is the minority class. The minority class here is the one, because it's the one which has the least number of observations. So it may perform poorly on the minority class, which sometimes may be of interest. The minority class may be of interest, but however, the model will perform so poorly on that one because it's a minority class, because of that bias we're talking about. Then my question now is, how do you avoid that biasness in the model when you have an imbalanced data like this?
Is it not
Hello?
possible to make the data size, make it of the same size, probably 250 instead of the 1:2, 1:1 by removing some of the data?
Very good. Very good. So all you need to do is to try to balance it, isn't it? You can decide to do it 50-50 or whichever one, but the ratio between the 0 and the 1 should not be that large. So you can use different techniques to balance it. You can check on what is called oversampling and undersampling. You can use any of those two to balance the data. So yes, so that is that. You should be able to balance the data. There are so many ways of doing that. All right. So just take note that when you have a problem like this and it is so skewed to one, you need to be careful. Maybe somebody can take it as his or her research to look at when you fit a model, which is this, and then when you balance the data, what will be the difference when you balance the data using different either oversampling or undersampling techniques. This is just giving us just some descriptives about the data that we are using, just something basic, just trying to describe the data. We have looking at the minimum, the maximum, and all of that. Most of the variables here, except this one, are numeric. So it's giving us a feel of how each one of them is. What we can do in other cases, you may have these features. Some of these features can be categorical. Yes, you can decide to draw some graphs of each one of them and even look at how each one of these and the target feature, how they relate. That can also be done. So there are so many things you can do before you actually start the modeling process. Now, as is always the case, in supervised machine learning, you need to split the data. You need to split the data, and it's up to you whether you want to split the data into two or you want to split it into three. If you decide to split it into two like we are doing here, you have the training data and you have the testing data. You can decide to do a 70-30, or you can decide to do an 80-20, whichever one you decide with. What it means is that you'll be using 70% of the data to train the model, and you now test the model that you have trained on 20% of the data, which was not used in training the model. So that can be done. So now I'm trying to split my data here, and in splitting, I am in my X. What I'm calling my X is just my features, these ones here, from this all the way to age minus that. So what I'm doing is I am dropping this class. I'm dropping the class, which is this. which is this one here. I'm dropping it. So I'll be left with only this one. So I have dropped the class, and the Y will be this one, our target feature. So it's just like having X. X is just all of this, and the Y is that. That is what I was doing here. So if you run that, it runs perfectly, and this is the Y. Now we go into dividing the data now into the training and the testing. Remember, we have X and Y. So for each X, we need to have a training data and a testing data. So what you see here as X underscore train is a training data, and X underscore test is a testing data. The Y train here, this is a target variable. So when I choose whichever percentage I choose of that, I'm also choosing that as well. So it must go with it because it's a supervised learning approach. So we need both X and Y. This function just is used to split the data. And this here, the test size of the data that we are using is 30%. If you decide that you want to do 80-20, then all you do here is to change here to 20. Then you'll be using 80% of the data to train your model, and then 20% to test your model. So I'll bring it back to 30. This is optional. It's just me having to say, okay, I have now split my data into training and testing. Let me just have a look at how my X train looks like. So this is my X train, and I'm just having to look at which ones were selected. Well, it selects, how do you call it? The observations randomly, right? It selects the observations randomly. So I just chose one of them. You can do it for the rest and just have a look. If you recall, you can do the same over there for shape, and then it will give you an idea how many observations are there in that one. So you can decide to do S train, then dot shape, and then it will also give you this value. You can try that. So we have successfully split our data into training and testing. Though that is done for every supervised machine learning model you want to build, whether it's regression or whether it's what? Classification. Because you want to be able to test your model and see how well your model is performing on unseen data. Yes, there's a question. Please go ahead. Please ask your question. It's Nathaniel, right?
Yes, it's Nathaniel.
Nathaniel, if you are speaking, probably you are still mute. So please unmute yourself and ask the question.
I said I want to ask about the random state.
Your voice is very far. I don't know.
Okay, maybe I will send it as message.
Okay.
Asking about the random states. Hello, Senor.
Hello. Yes.
Yeah,
It's
he's
asking
asking
what?
about the random states.
Oh, this one. This side.
Yes.
Okay. So this is okay. I think last time I talked about it, but let me just It's a parameter which you find, it's one of the parameters you find in that train test plate, which controls the random number of generators that is used to shuffle the data. So it's just there to control it. It ensures that each time you run the code, you get the same splits. If you don't include it, when you run the code, you see this for the X train that you have here, if you don't include it, when you run it, these observations that were selected, when you run the code another time, a different set will be selected. So you end up having your metrics changing anytime you run the model, because the observations that are being selected for the X train, the X test, the Y train, and the Y test will be different each time you run the model. You want to control that. Nathaniel, is that okay?
Yes, thank you. I also want to ask if we change that value to something else, maybe 40, 42, does it affect the accuracy?
The value is just a value. It's just a value. It's just like for those who use R, it will say set seed, and you just put a value in brackets, 1, 2, 3. It's just all it does is to ensure that the same randomization is used. The same set of observations are obtained. All right. Then from there, the next thing you want to do is, after you have successfully split the data into training and testing, you now want to go ahead and build your model. You want to now go ahead and build your model. And when you build your model, remember, you'll be building your model on the training data, right? You are building a model on the training data. So this is the function that is used to build a decision tree classifier. Remember, we are looking at classification. So if it was regression, it would have been different, right? And you may decide to put this in brackets. Sometimes you may decide to leave it. I'm just telling you that this is the criterion that I want it to use. There are different criteria that one can use, right? So I build a model, and now I'm fitting it on. So what you see here, this name here is the same as this name. It must be the same. So whatever name you give it, it must be the same. You may decide not to bring this, it doesn't matter. But what you find here is what is here. And what am I doing? I'm trying to fit this model that I have built, this decision tree classifier that I have built, I'm fitting it on my training data. My S train is all of this. So, sorry, yeah, it's all of this. It's all of this. Then if I were to do X, sorry, Y train, it gives me, you can see, it gives me the same set of observations. So this would have been my Y, which is my target, which is what I have here. And this S train is this. The test data will be there. That is what you use to evaluate the model. So we have done that. Then after you have built, let me run that. I don't know if yeah. After we have built the model, you want to use your model to make predictions. Well, in certain cases, you can use the model to make predictions on both the training data and the testing data. You can do that. But the one which you shouldn't leave out is the testing data. So here I am predicting my testing data. I can still use the model to predict my training data, just to see how it performs on my training data. I can still do that. So I can still do this and replace this by train. I'm trying to see how well it performs on my on my training data. So let me call it Y train. It's just a name, I'm calling it Y train. And I will now have to change here to train. And the name that is here must be the same name that is there. So this will be on the training data, and this will be on the testing data. So I want to see how well it performs on that. I think I ran this already. Let me see. So look at it. On the training data, see the accuracy it's giving me. 1. What is that? 100%. It's giving me it's telling me that the model, when I'm testing the model on the training data, it's giving me 100%. Clearly, you can see there's something going on there, right? You can start suspecting that no, there is some overfitting which is ongoing there. Then on the on the testing data, the accuracy is 0.69 thereabout. So you can see that, look, how can a web model be performing so well on the training data, but on the testing data, it's just about 68.8%. Clearly, you could see that maybe there is some overfitting going on there, but we'll deal with that later. Now, there are other ways that you can evaluate your model. There are other ways you can evaluate your model. You can look at precision, especially when you are dealing with classification algorithm. You can deal with precision, recall, F-score, and all of those things. You can let all of them come using this code here. Helps you to be able to get that. So that is what I just did here. And it gives you the precision. Remember, you have precision, you have recall, and F-score, and all of those things. You are able to get all of that. So that is what is happening here. And I'm doing this on the test data, you can see. Again, you can do the same thing on the training data. You can do the same thing on the training data, right? This part here is just for the confusion matrix. So I decided to take it out and I took it down. So when I run this, oh, no, this is a classification report, sorry. This prints a classification report. This prints this. My apologies, that prints that. Then after getting my classification report, which includes all of the other metrics that I can use, I then try to look at the confusion matrix. This is a confusion matrix using this code here, confusion underscore matrix. When I run that, it gives me the confusion matrix. I'm sure we are conversant with this confusion matrix. It's very small. There are other ways you can draw it. So I have also included other ways by which you can do the same thing differently. So I decided that, look, let us have a different way of doing the confusion matrix. And in this is a code. This is a function for the confusion matrix. Then what is this? This is the target variable for the test data. And this, if you recall, this y pred is what is here. This, the prediction that you made using the test data. So if we were doing that for the trained data, we would have been writing this there. So this is the prediction that we're making for the test data. So what I'm doing here is trying to create a confusion matrix using the model for the test data that I have. It gives me that, which is similar to this. You see, the same thing, not similar actually, which is the same. 116, 13, all of that. But just that now you are able to see where your misclassifications are. So which ones are being misclassified here? Maybe just to see if we have an understanding of this confusion matrix. Okay, let me start. Which ones are the correct classifications? Anyone? Which ones do you think are the correct classifications here? Because you see, in doing this
43.
prediction, you cannot be 100% accurate. There are times where you misclassify, but you want to limit them. But let's start with the ones that are correct classification. Sorry, go ahead, Vincent.
43.
43, yes. So 43 here is saying that the true label is 1 and the model predicted it to be 1. So the true label is 1 and the model predicted it to be 1. That's true. Which other one?
116.
116, correct. The true label is 0 and the model accurately predicts that to be 116. Then the misclassifications over there are what? 30 and what? 42. The misclassifications are 30 and 42. In the classification algorithm, you want these two values to be very low. You want these two values to be very low, and you want these ones here to be as high as possible. You want this to be high, you want this to be high, but these are the errors that you make when you are classifying the model. I'm sure you've heard of type 1 and type 2 errors, right? So those are the errors that you make when you are doing the classification. So that is the confusion matrix. What I have here you may ignore it, but for those who are interested, I just created a function. This is the simplest way of doing it. But then you see, when you are coding, sometimes maybe you are building this model and you build other different models. You want to use this function to generate the confusion matrix. I just decided to write this function and call the function to be able to give me the confusion matrix. So this is a function that I wrote just to be able to create a confusion matrix. So what you see here as make confusion matrix is the name of the function. So I call it, so I'm defining a function and I'm calling it make underscore confusion matrix. So for those who love programming, they may want to go into this, but if this will confuse you, this is the simplest way of creating a confusion matrix for your classification algorithm. But you can still look at this and create a confusion matrix using a function. I just call the function. I put the model, the name. This is the name that I call the model that we built. It's called model. Whatever name you give it here, it's the same thing that you find here. So when I call the function, what I'm doing here is calling that function, the function that I have written. You can write a function to find the average of values from 1 to 100. Right. So when you call that function and you give it some values, you're just asking it that find the average of those numbers. So you can write a function to make averages, right? So that you don't have to be adding, whenever I give you a new set of numbers to add, you don't need to be doing the additions again and again and again. You can just call that function, give it, and then those numbers, and then it will perform whatever task the function is supposed to do. So that's the same thing that I was just doing here. So when I run this function and it runs well, I just call it, give it the model, and this is what I want it to do for me. And yep, it gives me the same thing. But this time around, I ask it to do some percentages for me, right? So it gives me the same thing, the actual labels and all of that, just like we got over here. You can see the same thing that we got. So I just created a function and then I add the function to do that for me. Now, the next thing that is normally done is you want to look at the tree. So you need to look at the tree that you have, because remember earlier on, I showed you the tree, the node, and then the decisions that were made and the splitting and all of that. You want to see that. And that is what I'm trying to do over here. But what I'm doing here is just trying to see the feature name, the names of the features that I have in my data. Remember, I called X. X is this. Everything I do, I have defined it. This is my X. This X you see here is what is down here. Where is that? Is what is down here. X dot column. So I want the columns of those X. And this is the column, which is just the features. And I just say, print them for me, and it prints them. So I want to be sure that, yes, it is the same features that I'm using for that. So from this library, I want to draw the tree. Now look at it. Look at how it looks like. This is a tree. And it is so complex. The tree is so complex. You can see so many splits happening here. It's just too complex. So when you have a tree which is too complex like this, what must you do? Anybody who has an idea what you must do to the tree? What do you think you must do to
Trim
the
it
tree?
down.
You must trim it down, isn't it?
Pruning.
That is what we call the pruning. You need to cut it down. The tree is growing too much.
Trim it
Growing
down.
too much. So you need to what? To cut it down. But then remember, we haven't done hyperparameter tuning. Whatever we were using to build the model here, we were using the base values of the parameters that we have in the model. We didn't do any tuning of what? Any of the parameters. So you can decide that, well, I have a tree from this model, which I think is too complex. I need to do something about it. But before then, what I can do is, well, one of the powerful things in decision trees is this thing here. It looks at the importance of each of the features in the tree. So how important, or the Gini importance of each of what? The features that we have. The first one is the most important, you can see. So the higher the score, the more important that feature is in making your prediction. So this gives us just the importance of each of the features that we have in our model. Oh, no, hold on. What I was trying to do here is, oh yeah. It's an indentation error, eh? I'll fix this. Just give me a second. I'll fix this. But what I was trying to do here is to look at the feature importance of each of these variables that are here. Feature importance, yes, importance, that's fine. Good. It was it was just an error of indentation. Sometimes this is what happens. It can frustrate you. So it's looking at the importance. So this bar graph, like you see here, is just going to confirm what is here. It's just confirming what is here. So if you look at the first feature here, you can see it is the most important, followed by this, which is this one. Then the third one is this. So what you have here can be put graphically in this format, which is there's the feature importance of each of the, how do you call it, the features that you have in your model, how they contribute, because not all the features contribute equally to the prediction. So you want to see which ones are most important, because they all not contribute equally. So here it's telling us that this one is the most important. Remember, what we have here is just a confirmation of what we had earlier on using the Gini index. Then, of course, when you are doing classification, one of the other ways is to look at the ROC curve. One of the ways is to look at the ROC curve. Right. So what I'm trying to do here is to draw the ROC curve. And here is, I'm calculating the probabilities. I call it threads one, whatever name I give here, you don't need to worry so much about the name. You can change it because I'm just assigning whatever is here. Remember, this model is the name of the model that I built. Let me say this model is not the best model anyway because the tree is so complex. We have to prune it and all of that, but we are using it anyway. Let's assume that that is the best model, but that what you see as model is what is here. Sorry, where is it? Here, there. So what you see there is the name that I called it. That's the name I called it. And true positive ratio, false positive ratio with the thresholds, I just added one. You can decide to remove it and call it FPR. I just added one to it, just a name. So you don't need to worry yourself so much. So I'm trying to build the what? The ROC curve. So that is the function that builds the ROC what? Curve. And now I'm trying to plot it. I'm trying to plot it now. And in doing that, I have that. Let me remove the name. There we go. So there is my ROC curve. I'm sure we all know how to interpret this. Anybody who wants to help us with this interpretation? How do you interpret this? How will you know whether your model is performing very well? Anyone? So for a model, you can see there's a red line here. Okay, sorry. Yes, Kobina, please go ahead.
Yeah, the lines have to be as close to each other as possible. That shows that the
Which
algorithm.
lines? So if you say the lines have to be close to each other, which lines are you referring to, please?
I think the blue line represents the actual predictions, and then the red represents the the red represents the actual predictions, and the blue represents those that were made by our decision tree. So
Okay.
when they lie parallel as closely as possible, then it shows that the decision tree is doing well. The true positives are matching well enough.
Okay. All right. Thanks. Anybody else? So what would you say if the blue line, so now we see it's blue and red, so I'll be referring to blue and red. If this blue line should fall exactly on the red line, what would you say? What can you deduce from that? If the blue line were to fall exactly on that red line? Anyone?
Sorry, sir. I thought it was a correlation plot. It's a
It's
yeah.
a receiver, yes, it's a receiver operation characteristics curve. So you want to correct yourself?
Yes, I wanted to try to correct myself.
Okay, that's fine. Go ahead.
We need to have a maximum area under the region. If the area is under the blue line is large, then it shows that there is that the model is performing well.
So when you say the area, I'm sure you are referring to this place, isn't it?
Yeah, yes.
Everything below here, everything below the
Yes.
red line, everything
Yes.
below the blue line, isn't it?
Yeah, yeah.
Correct. So now I agree with you. So this whole area, if you look at the whole area, what is the value of the whole area? Anyone? What do you think is the value of the whole area? This whole area. What is this value? Is 1.
Yeah.
So the area, the whole area there is 1. So the portion below the red line is 0.5, and the portion above is also 0.5. So that gives you the area under the curve, which is what is here as AUC. So the area under that curve is, for the whole thing, it's 1. So if you have a model, which is, the model is the blue line. If you have a model which is falling exactly on the red dotted line, then you expect the area under your curve to be 0.5. Under normal circumstances, you want your area to be as high as possible. For a model that fits very, very perfectly, your area under the curve will be 1. So that means the blue line, this blue line, let me use this. This blue line, where is the pointer? This blue line will go this way and that way. Sorry, my drawing is not too good, but the blue line will go that way. Then meaning that the whole area is what? Is 1. But if you have the area under the curve being 1, you are very suspicious of that model to say, how can the area under the curve be exactly 1? It's very suspicious. It's a sign of overfitting the model. It's a sign of overfitting the model. But if you have the blue line to be below the red line, if it's somewhere here, what will you say? If it was here, what will you say about that model?
It's underfitting.
It's underfitting. It's terribly, terribly underfitting. The area, you expect the area there to be below 0.5. But you expect that the area under the curve for a model that is performing fairly well should be more than 0.5. So you expect this to be high. So whatever you are getting here should be corresponding, let me clean this, correct, okay. Should give us same information as what the results we got above. It should give us same information as the results we got above, right? So that is the area under the curve. Then comes the issue of hyperparameter tuning. Because now I feel initially we built the model using the base values, but it may not give us the best prediction. Because it may not give us the best prediction, what you normally want to do in every classification or regression model is to select the best combination of the hyperparameters such that it gives you the best prediction, whether it's the accuracy or whatever you are interested in. So that, we said, can be done through the process of hyperparameter tuning. And one of the ways is using the grid search approach. So we are implementing the grid search here. What you find here are the parameters. So it will be doing a combination of them. It will be doing a combination of these parameters and trying to choose the ones that best gives us a high accuracy. And in doing that, we've also included cross-validation. I'm sure you have done cross-validation already, isn't it? Who wants to tell us what is cross-validation? Or what you know about cross-validation?
Sure.
Yep.
You can use it to test if there is stability or the result.
Sorry, say that again.
Just testing if the result you are getting are stable.
What are the results? So how do you do that? How do you perform cross-validation? Maybe you should give us an idea. If you were to perform cross-validation, what do you do? How do you do it? Any idea?
So
Yeah, go ahead.
with cross-validation, it's more or less like splitting the data into usually
Good.
3 sets into training, validation, and then testing sets,
Mhm.
where the validation set is also known as a cross-validation set.
Okay. Yeah. So that is what we are doing here, right? Here I'm doing fivefold. There are different techniques for cross-validation, right? There are different ways of doing cross-validation. There are, but here I'm using the CV of 10. That you can do, sorry, 5. You can do 10-fold cross-validation, or you can do 5-fold cross-validation. The choice depends on you. The choice is yours. You can decide that you will compare 10-fold cross-validation to a 5-fold cross-validation. You are just trying to determine that the effectiveness of your classifier, and to make sure that it does not overfit or underfit. That is what the cross-validation is doing. So what it does is that, you see, it's a statistical method that you can use to compare and evaluate your model through the process of dividing your data into different segments. So one segment, like our colleague said, will be used to train the model, and the other will be used to validate that model. One of the commonest one is a K cross-validate, the K fold, where the K represents the number. So in this case, my K is 5. But you can use, how do you call it, 10 to do that. So you may, in your capstone, you can decide we want to compare 10-fold cross-validation to 5-fold cross-validation, and see how do you call it, how they perform. Because for the okay, let me leave it at that for now. Let me leave it at that for now. I'm sure you have done. Have you done cross-validation? They did, right? You did a theoretical. I don't want to go too theoretical. So here I can decide to change this to 10. If I change this to 10, I'm doing 10-fold cross-validation. Good. Then now, after I have done that, what I do now is I want to make a confusion matrix for me again. Now, look at it. After we have done the cross-validation, I build the model again. And if you compare this to the previous one, you see that this has improved. Do you see an improvement compared to the previous one? That, I think it was 116, but now this has increased. These two have now decreased. So when we did the grid search approach and incorporated the cross-validation, we have been able to improve the accuracy of the model. That, I don't want to do this. will be used to check the accuracy on the training set and the accuracy on the testing set. You can see that it's a bit closer. So here, I could say that, well, I'm not suspecting any overfitting in this process. Now, let me plot the tree and see how it looks like. Now you can see that now my tree looks better than the first one. But now let's take a look at this. You can see, can you see where my cursor is? I want to draw your attention here. Good. The first thing there, it represents the number of nodes. So you can see this is node 1, node 2, 3, 4, 5, 6. It goes all the way down. It just represents the number of what? Of nodes. Then this part here, it's a decision. The decision was made. And what was the decision? It says that when this variable, when this feature, this is one of the features we have in our data. When this feature is less than or equal to 129.5, let us go this way. If you have this feature to be less than or equal to 129.5, we need to go this way, that decision. Meaning that when you go to the data, every observation which has that feature which is less than or equal to 129.5, we need to follow that true arrow, this arrow here. We need to follow this true arrow. We need to follow that. And anything that is more than this must go in the other direction. That is what this means. Good. Then I'll come back to this. Let me speak to this one here. Okay, so the Gini, let me speak to the Gini index. So the Gini index there, it refers to the quality of the split, and it's always a number that is between 0 and 0.5. If it is closer to 0, then there's high purity in that node. So you want that value to be reducing so that it is closer and closer to 0. Then there's high purity in the node. If it's about 0.5, then you can say that there's high impurity. There's high impurity in that node. So yes, when you're here, you can see this is 0.4. It's almost close to 0.5. There's high impurity in the node. We need to keep splitting down from that node. So this is the parent node, and then we now decide, let us split down. Now, when we split down, look at what happens. So anything that is less than less than or equal to 129.5, we are here. Then when we are here, it picks another one. This is another feature. So you are less than 129.5 and less, and then the mass is less than or equal to 26.9. Or this side says this feature is more than 129.5, but the mass is less than 27.85. So you keep splitting and going down and down and down. Now, then there are two values there. If you add this and that, please add these two values and tell me what you get.
$537.
It gives you this value here. Right. Now, this tells us how many samples at a given node will fall into each category. So of the 537 observations at this level, 354 belong to this class. And 183 belongs to class 1. This class here represents the majority class in this node. So in this node, this class, which is 0, remember in our data we had 1 and 0. So this class, which is 0 here, is the majority class in this node. And the total number of observations is 537. Of these, 354 belongs to the class 0, and 183 belongs to the class 1. That is why we were saying that this class is a majority. And you can see it follows through for the rest as well. If you come to this side, still is the majority class. Is the majority. Here, now you can see it changes. The majority class is now what? 1. You can see there's a change here. This is a majority class. There's a change. So this, because this now is more than that. That is why this has changed to 1. That is why this has changed to 1. Right. If you have a question, you can ask about that. Then we can see that after we have done the grid search, which allows us to choose the best combination of parameters, our model performs quite better. Our decision tree is looking quite simpler. The previous one was very complex, but we managed to reduce it. We haven't done much. We just did how do you call it? What's the name? Parameter optimization, and that has led us to getting there. So again, the same things we did before we did the parameter optimizations, we do the same thing again. We look at now the importance of each of these features again. There we have it there. And then we draw it. I think the same thing. So you see the error is telling us unexpected indent. So you find this, Python doesn't like that. You find this and it will tell you that, yes, you need to correct that. So this, again, is telling us that this variable is the most important in our prediction, followed by that, followed by that. Good. Is there any question on this? I haven't touched pruning because I thought we will not be able to finish that. So when we meet next week, I will show you how to do pruning And then also we will take a look at another model. We will look at random forest. Today we are looking at decision trees. Next time we'll look at a boosting algorithm. Probably we'll choose random forest model. And in there, I will do regression. I will not do classification again. Is there any question, please?
Thank you, sir. I would like to know how to do export this output. Yesterday, I failed to do export.
Oh, you just right click. So this graph here, if I want this graph, I just right click inside here.
Yes.
I can
Before
copy it.
the
I can copy it. You can copy it and paste it wherever. You can.
I mean the full output so that you can have you save it in like a PDF, but I failed to do it. So
So what do you want to export?
we export the whole model in a PDF. When you pass it through the file, then the file in the corner.
I'm struggling to understand exactly when you say you export the whole thing. Maybe if somebody understands, maybe can somebody explain to me?
Do you want the notebook to be in PDF?
Yes.
You want the notebook? I think he wants the notebook to be in a PDF. Do you want that? Or
Yes, please. When you pass it through this file in the corner,
but if you put it in PDF, how are you going to run it? I'm not sure. You want to take it to PDF, isn't it?
Yes, please.
But how will you run it if you take it to PDF? I'm not sure. Do you want to still run it when you take it to PDF?
Yes, when you pass through this in the corner, you see where there is a file in the corner, in the left corner. You pass through there.
Yes.
There, then
yes.
You go to
save notebook, right?
Save and export notebook as.
Save. Where is
Save,
that?
Save as and export.
Oh, you want to do it this way?
Yes, but when you
but if you take it to PDF, okay, let's take it to PDF.
You cannot get it. I try many times.
Okay. Or even HTML. Let's do HTML. Oh, now I see what you're talking about. Let's do HTML. Isn't it the one? Let me see. It doesn't look like it's coming to PDF, right?
And also, when you try to copy if you try to copy this figure, it cannot come. Try your best and show us if it can be.
Let me see whether the HTML will come. Just hold on a second. Let me see.
I think under the file, there's a download over there. If that one can be used.
No, what he wants is he doesn't want this.
Yeah, when you click download, you get the codes and also it is opened when you run it the second in the application.
He wants to save and export the notebook as a PDF.
As a PDF.
But
Yes.
why do you want it as a PDF? Maybe we can help you, maybe an alternative.
Let me try it again.
Or in any format you can
Okay.
do
Now,
export.
let me see. Let me see.
I think as she's saying, like if you let us know why do you want it in a PDF? Is it just for your reading
Maybe it's for his reading.
or for you
Probably.
to go through the code, or do you want to run it as a PDF? Because it's not possible to run it as a PDF.
And that's what I'm
You
trying to
can just have
understand.
it as a PDF to just be reading through.
Okay, now let us now copy the one figure there. Try to copy one figure and paste it elsewhere, either in a Word or in a PDF, in a PowerPoint.
Okay, I'm coming.
You will see what is happening.
But you can save it.
Yes, copy this figure.
Hold on, there's something. There's okay. So I should copy it, right?
Mm-hmm.
And then let me put it here. Hold on a second. No, but I think you rather want to. The best will
For me,
be
I think the simplest thing I would have done is to screenshot
copy.
what I want into a photo format and then convert the photo format into PDF, and that would be
No,
simple.
but I think you can even do copy.
But you can even save in the code. Like there's a code to save the generated file.
There's a way you save this. Hold on. Rachumezi, please help me. Let me close this.
Yeah, so I think
There's a way you can even copy this. You can output this. I did that before. No. Is it this one?
I think he can click on it and right click and copy. You can hold the shift key and right click.
Yes. And then I right clicked. So now when I copy,
Hold the shift key and right click.
okay.
Yes, then you can
Yeah.
copy the image.
Save. You can even save it.
Yeah, and save the image. Yeah.
Okay. Thank you. So we can save. Yeah, we can save it as whatever. Okay, that's fine. Thank you. So the shift right click, you can save it. Thank you. Or copy. And paste. Okay, so it's a shift, right click, you copy or you save. It's shift, right click, you copy the image or you save the image wherever you want to save it. I'm trying the option that you are looking for.
Okay, this is working. Okay, thank you. Now
Yeah. Let me try that.
shift and the
Shift, yes, shift and then right click.
Yes.
Why is it not
Thank you.
giving me HTML? Okay. Okay, so it's a HTML. Oh yeah, here it is. Oh yeah, here's the HTML. So it's been downloaded to HTML. Can you see it? So now it's in HTML. Can you see that? Hello, Vincent.
Yes, please.
Can you see that it's exported to HTML?
Yes, I ran it. I have those figures, no problem.
Oh, okay, okay. So for HTML, it seems to be working.
My problem was to do export and copy, but copy is done,
PDF
but
that I don't know
exporting
why.
the whole document is not possible.
Okay, the PDF needs some files. I don't know. Let me install them and see whether it will convert it to PDF. There we go. There's the PDF. You did. Can we see the PDF? This is the PDF. Isn't it? Gave us a PDF. Are you there?
Yes, I'm seeing it. But
Yeah.
when I try to do
You do
it,
it yourself. You didn't. Okay. So you give us a PDF where you can actually go through each one of them. Okay, that's fine. So what I would do is I'll do the code, convert it to PDF and share with you with the results.
okay.
Yeah.
Thank you.
Cool. All right. Any other questions?
And then what if we have multiple classes?
Yeah, you can have multiple classes. You can have multiple. You can have three classes. It's the same thing. Because classification is not restricted to only two classes. You can have three. Probably, maybe I should look for a data set which has three classes, and then will you want me to run the code on it and share with you, or give it to you to try it? What will work best for you?
It would be good for us if we share the code for multiple classes.
Okay, that's fine. Let me just take note of that. I think there is there's a data set, a popular data set. I think that the iris data set is three classes, right? I think it's three. I will look at that. I think the iris data set it has three classes, so I'll try and look at that one. Is there any other questions? But like I said earlier on, we'll look at random forest, but before random forest, we'll go through the process of pruning and all of those things again on this one. Then we will do random forest as well. But in that case, we'll do regression because we've done classification today. So we also need to balance it and do regression.
All right. So I think
Okay.
we are going to allocate time for that. And we are going to announce it to the group so that we know what time we're going to do it. I think we're going to do the next week. We have Professor Givisa. And so let's all take notes and let's all come accordingly. He's expecting us, and we are also expecting to have a good interaction with him. And so let's all make it a date and then let's show up on time. If you have not registered, please register for the meeting so that when I send information about the meeting, you will also receive it. So thank you very much, Senor, for taking us through this part. After Professor Givisa, Senor will come back to continue with the regression as well. So thank you everybody for coming around, and God bless you, and see you next week. Bye-bye.
Thank you, sir. Have a good night.
Yeah, you too. Bye.